In this video, we're going to take a look at an example where we are going to find the intervals where our function is concave up and the intervals where it is concave down. Our function here is f of x equals x to the fifth minus 5x plus 2. So to determine those intervals of concavity, we need to first identify, are there any places where our function is undefined, anything that's not in the domain of this function. And this is a polynomial, so it's defined everywhere, so there's none of those places. Next, we need to find where is it that our second derivative is 0, or where does our second derivative not exist. So let's take our first derivative. So our first derivative is going to be 5x to the fourth minus 5. Our second derivative is 20x cubed. We will take that second derivative and set it equal to 0. So that will happen when x is equal to 0. So 0 is a potential location for a point of inflection. We aren't guaranteed it's a point of inflection. It's just a possibility at this point. And so now we are going to do a sine chart. We're going to go from negative infinity up to 0. And then we're going to go from 0 all the way up to infinity. This is a sine chart for the second derivative because the second derivative will tell us about concavity. And so, if we were to plug in something smaller than 0, so negative 1, we're plugging that into the second derivative. So if we plug negative 1 into this, negative 1 cubed is still negative 1 times 20 is negative 20, so that is a negative value. If we plug in something to the right of 0, like positive 1, into the second derivative, we will get positive 20. All we care about is the sign. And so what does that tell us? Well, it tells us that f is concave down on the interval from negative infinity to 0. And f is concave up on the interval from 0 to infinity. In addition to that, 0 comma f of 0, which is 0 comma 2, right? So f of 0, we're plugging 0 into the original function. If we plug in 0 there, we get 2 as an output. 0 comma 2, that is an inflection point. It changes from concave down to concave up right at that point. And that is how we go through and determine whether a function is concave up or concave down on an interval. Come back for our next video where we will do even more examples of finding intervals of concavity. We will start to look at some functions that are a little bit trickier. We will ramp up the difficulty. We will see you there.